and welcome to Func Prog Sweden. My name is Magnus, and I'm the organizer of Func Prog Sweden. First, warm welcome to all our recurring guests. Thank you very much for following us at Func Prog Sweden, and thank you very much for your participation and your shout-outs in the chat and all the questions you ask. Thank you very much. It means a lot to me and all the other organizers, but also a lot to the people doing presentations here at Func Prog Sweden. And to all our first-time visitors to Func Prog Sweden, this is the meetup and YouTube channel where we explore functional programming and functional programming languages, concepts, and more. You should check out all our old YouTube vids where you can find a lot of good content. Now, let's head over to today's agenda. First, me, short introduction. Then, Erlang, nearly in space, by Dieter Schön. Dieter has built a test framework that tests satellites that are sent out into space. And once in space, yeah, you can imagine it's hard to do updates, meaning it should work. Then, replace your ORM with relational algebra by Christopher. Are you tired of doing database stuff? This might be a solution for you. Check it out. And in the end, as always, if you have more questions, anything you want to ask the presenters, head over to the Discord server where you can ask them. First, I would like to present or thank our video sponsor, Otherbeat. Thank you very much. If you want to know more about Otherbeat, head over to their webpage, otherbeat.com, or check them out in social media. Then the schedule for the coming spring. 18th of March, we will host an in real life event at Kivra. So if you are in Stockholm and at 18th of March, make sure to check out the meetup and come and see us in person. There will also be, we will announce the presenter within a week, and I think it will be very interesting. 16th of April, we're back again with another meetup, and then we haven't decided the dates yet for May and June. Oh, it says May and May. Anyway, May, and of course, we will come back in June also. To support Func Prog Sweden, make sure to follow us and subscribe us at Meetup and at YouTube. And if you want to ask more elaborate questions or things to our presenters, please make sure to join the Discord server. You'll find an invite below the channel or in the meetup group. And if you have any questions during the presentations, use the YouTube chat or, as I mentioned before, the Discord server. So with that, let's start. Welcome, Dieter, to Func Prog Sweden. Hello and welcome, Dieter. We are looking forward to your presentation, Erlang nearly in space.
Thank you.
You're welcome. The stage is yours.
Okay. Hello. My name is Dieter, and as Magnus told, I'm applying Erlang to test satellites while they're on the ground and being manufactured. So, a bit of an introduction. I work for Thermo, which is a Danish company, and my department is located in Vienna. We are working in the space business, have been working for the last 40 years. I have been here for the last 25 of them. And yeah, our test equipment, which we produce, is usually delivered to spacecraft manufacturing companies, as the Airbus, Thales, in Germany, OHB, and is used there. Now and then I will need to introduce abbreviations. A SCOE is an abbreviation for such a test system. It's a special checkout equipment. Some of these systems are transported to the launch site where the rocket is launched and provide the spacecraft with power until the last moment when the rocket launches. Personally, I learned what I started with was Fortran. In school, we had an old IBM, and later I also used PDP-11. This should give you an impression how old I am. And more privately even, I'm married. I have 2 boys, which are nearly no longer boys. They're 18 and 16. And I'm working and living in Vienna. So this would be a typical setup at a spacecraft manufacturer. This is probably an engineering model of a spacecraft. An engineering model is designed to get familiar with the spacecraft behavior, and it's never intended to go into space. Therefore, it doesn't need to look like at the real spacecraft. And this rack, I hope you can see my mouse pointer. This rack in the background would be one such test system delivered by us. This actual picture was taken at SCOE in the Netherlands for the Galileo systems. So, and at the spacecraft manufacturer, the test topology looks like this. The green block represents the spacecraft, and there it has several components depending on the spacecraft. Communication for radio frequency, power, usually it has a solar array and a battery, and several instruments depending on the purpose of the spacecraft. All is controlled via a central checkout system, and then there are dedicated test systems which each test one functionality of the spacecraft. And these systems are produced by my department. And as I said, there are different stages of testing. You start with an engineering model, which is not designed to go into space. Then you have a pre-flight model. Depending on the success of the test campaign, this may go into space. And then you have one or more flight models. For the first Galileo stage, there were 4 flight models. And for most of our projects, it's only one satellite. In 95% of our projects, the customer is ESA, and they built nearly exclusively scientific satellites where you only need one of a kind. Internally, we have 4 subdivisions. We built radio frequency SCOEs, which test the communication part of the satellite, power, which test the set array, the solar arrays, and you also have to test the eclipse when the spacecraft goes through the Earth, to the shadow of the Earth. It's necessary that it's still powered by the battery. And yeah, this has to be tested. And our test system can also act as a load. If you want to test the battery, then we simulate the spacecraft and we consume the power of the battery or the solar array. Next subdepartment is instrument or payload SCOEs. There we have data interfaces to the instrument, and we test all the functionality of them. And last subdepartment is not space related. Some colleagues have a new application for our power devices and found that they could, with some adaptations, can be used to be used as a battery cell tester for the automotive industry. So this is an RF rack. It's a 19-inch rack, usually around 2 meters high, with spectrum analyzers, network analyzers, signal generators. So the signal generator sends the signal to the spacecraft, and the analyzers then measure the quality of the signal. And because you can have several tests, we have switch control matrix, which can route the signals on different ways. So you can test all the relevant subsystems of the satellite. And in the bottom layer, there's the power distribution unit. Oops, wrong direction. So most of our applications are have been written in C++ or Tcl, have a fixed architecture. So it's bespoke software. For each mission, no mission is like the other. So you always have to make bespoke software. And what was that? Anyway, so we have this approach to build an application for one mission. And I thought of, it's of course a reinvention of the wheel, to build a modular system which can be used to quickly have application which uses this standard building blocks and quickly compose an application of it. What fascinated me on Erlang was the actor model and the binary pattern matching. It's super fast to write parser for a binary network protocol. And I also use the late binding mechanism. I call it this way, it's not in the official Erlang documentation, because you can send a signal to any process, and you could, by using a different process module as the receiver, you can have, and then you can exchange this during runtime. So I will come to this in the next slides more deeply. So my idea was we have the same, a common set of requirements in our missions. We have a set of network protocols. We have sockets or file interfaces. And there are, I think, a dozen more building blocks which I defined. And I gave them standardized interfaces, so they are able to receive the same message. And I can very easily, for example, replace a socket with a file, or I can replace the CNC interface with the Eden interface. Or I can, if it's only a receiver, I can use the pcap module to save it to pcap files which can be read later with Wireshark. And the second thing which I use in my framework is programmatic configuration. These little, I'm not sure if it's readable, but these little yellow boxes represent instances of these building blocks. And I have functions, an API, which is able to define such a tree, and which then, if applied at runtime, create this tree of processes where these are supervisors. And so you can quickly instantiate an application. And if you have the need for a different application, then it's just a matter of using a different configuration file or just removing this this device tree and instantiating another, then you have a completely different application. So next, I will introduce some of the missions where I used my framework. The first was for an instrument SCOE. It was the microwave sounder for a METOP satellite. Here I had a problem. If you have seen the movie Apollo 13, they had a problem with air filters. They had round filters and square filters, and they didn't match. And in my case, I had a problem. These two were applications from the customer, which spoke different protocols. And the screen block was software which could talk either one protocol or the other, but not both at the same time. And it was necessary to connect both. And oops, my solution was the red box, which I was able to do with instantiating one block for the CNC protocol, the other with Eden. And I had another module which was able to transpose this protocol units. So this was then the solution for this problem. My second project was for the Space Rider, which will be this part here, a reusable container for supplying the ISS or maybe some future similar space stations. The customer had two power SCOEs, which were meant to run in the redundant scenario. They both supplied they both were connected with the spacecraft. And in case of a failure of one of them, there should be instant hot standby switch over to the other system. And one requirement from the customer was that the central checkout system should only see one SCOE, one virtual SCOE. And my solution here, called Hot Red, was to distribute the commands in the direction from left to right to both of the SCOEs, and the replies only use the one from the active. So one problem here was because I just read what was coming in on the socket and sent it immediately out. Those packets were from time to time subject to the TCP segmentation. And if a failover was happening right in the middle of a segmented packet, then the CCS received a partial packet and closed the connection. So I had to introduce a bit of a higher protocol-aware layer to reassemble the packets, and I introduced an update to the customer and have not heard anything ever since, so I assume it's running. The next project was for application was for RF SCOE. The project is Cristal. It will be a mission to measure the ice thickness, if I can read it correctly. And we produced two versions for different radio bands, for the KU band and for the KA band. The hardware was Beaglebone Black, a small embedded device about the size of a credit card. And because it has an eMMC memory, initially we thought of using a Raspberry Pi, but there are only SD cards are available, and the customer rejected this idea, and because of eMMC is more reliable. We had some hardware-related problems, but there were no big blockers. It's just the BeagleBone Black has some I/O pins, and most of them have 3 or 4 functions. And if you have connected the wrong pins during the system during boot, then it behaves a bit funny, but we learned our lessons. And the system also has a network connection similar to Skippy, which is used in measurement devices. So this is a picture of the RF parts. The blue cables are microwave cables. In the upper part of the spectrum at 40 gigahertz, I think the wavelength is about 7.5 millimeters. So it's very important that the length of these cables is matching. Otherwise, you get some phase differences and a lot of problems. I'm not an RF engineer, I'm just laying what the colleagues had to find. And the other side shows my BeagleBone Black. I have connections to this RF switches and also some temperature sensors here. And there should also, here's the network connection. These are my interfaces. And I also wrote GUI, just a small web interface, which can be used to control the device from a PC or laptop switch position. And you get the real-time reading of the sensors. This is done in Elixir with live views, so it was quite easy to get the real-time info from the device to the display. So now we are leaving the space domain. This is for a new product, the battery cell tester. It's here in the test setup. This is not the final version. And in these 2 racks are several power supplies and measurement devices. And somewhere here should be a 19-inch controller, which contains my test framework, which I wrote. It uses test scripts written in Erlang, and where you can define test sequences to test all necessary interfaces of the device. Well, I'm sure it's not completely video. This would be one example of a test sequence. In the beginning, there's initialization of the test devices. I have this is a duck which is here to collect measurement data, a power supply. All these devices are defined in a Postgres database with their IP addresses, their limits, their serial numbers for test reports. Then the main part of the test sequence would be to apply power, to make measurements, to loop and measure a current in a loop. And at the end, to make it an automated test system, there are functions which check if the measurement values are in the defined ranges, and so to conclude if the test was successful or not. And the system then produces a test report in various formats, in JSON, CVS, CSV and PDF. Depending on what is tested, I dynamically can load the needed instruments. And so this is would be one test with 2 devices, and another test which uses 5 devices. And yeah, that's about it. Then, because some colleagues were very paranoid, and the device under test is quite expensive, so it's necessary to protect it and do not let it destroy by wrong, for example, voltages of the power supply. So I wrote an AP. Well, I used the Erlang functions to read a script from a file and to parse it into tokens. Then I can, if needed, I can add variables into the state of this interpreter. And if I then execute, this is done in a loop, I can intercept each function call and, for example, check if the voltage is in the allowed range, or if some errors have been introduced. So this is just a peek into my next project. It's called MechSim. It will be the simulation of stepper motors on a spacecraft. There can be up to 60 stepper motors in a spacecraft for the solar arrays, for the positioning of thrusters or antennas, and they also have to be tested. And the idea here is to simulate the stepper motor. The spacecraft will send the stepping signals to our test system. We will read the signals, then calculate the new position of the stepper motor and respond with a virtual potentiometer readout, which gives in analog the virtual position of the motor. So this is in the design phase, and there's not much more than this sheet here. So conclusions from my test system. Erlang is very suitable for my way of thinking or of working. In other programming languages like C, C++, or Python or whatever, when a project reached a certain state or size, I tend to lose the focus and the overview. But with Erlang and the modules, it is for me quite easy to keep the overview and to know what functionality is where and where I have to look if I need to make some adaptations. The other items are, well, the usual, the properties of Erlang. There are no global variables to spoil the namespace. I use exclusively gen servers, so the internal state is encapsulated and not visible on the outside. It has nothing to do with OO, which suits my mind very well. Rebar Auto. This is Rebar is building tool for Erlang, and Auto is a module which rebuilds every time a file is changed. So if you write your code so that or in most cases, when you do a file save and do not change the internal structure of process, then they will survive and have automatically the new state applied. It's like hot reloading just in the development phase. And also the single assignment of variables is very nice feature for me. There's only one assignment to a variable, and then I know what's in there. I think, yeah, that was my last slide. That concludes my talk, and thank you very much for listening. Back to you, Magnus.
Thank you very much, Dieter.
Thank you.
Yes, let's see. I'll take a question immediately that came up in the chat. The question is, I didn't get the custom DSL to launch process. Is it similar to the .app file that holds the metadata for the application behavior?
But I did not understand at the beginning. I did not
Like
get
when you launch the DSL,
yes.
how do you use, how do you load the metadata?
When you mean here when I said that I can inject variables?
Not really. I think it was earlier. Anyway, yeah, inject variables, but like how do you use the metadata? Where do you store the data for the test as such? Do you use them as metadata, or I would say like the test data, you know, the data you need to like instantiate the actual test.
Yeah. The data which are or in this test bench environment or test parameters come from a Postgres database. And yeah, afterwards the results are also written back to a Postgres database. And where I do not use much of the functionality of Postgres. I use it more like a key value storage. With, of course, all linked together to represent in sum the result of one test sequence.
How do you present the data? Do you use the common test output, or do you use some other like dashboard or something to present the data for, like, I don't know, stakeholders, developers, whomever is interested in?
I use common test to test my software internally, but for this test bench, the primary visualization is PDF reports. With tables, and I can include graphics, mostly XY plots. And for some colleagues who will use my test results, then they can export the test data as JSON or CSV files.
Okay. Yeah, from the Postgres database, you mean?
Can be used exported from Postgres, or I also directly, well, no, I have to correct myself. It always comes from a Postgres database. This is the source, the single source of truth.
Yeah, yeah. You need one single source. It's usually easier than to have multiple sources. No more questions in the chat, but I'll ask you, like, when did you come in contact with Erlang, and how did you? How can you pick it up?
That was about 10 years ago. A colleague was coming back from a trip to, I think it was Stockholm. There was a meeting about, I think, functional software in more general. My colleague was coming from the Haskell side. And when he came back, he gave a short talk about his impressions. And he mentioned Erlang. And yeah, then when I became, I got big ears and investigated and researched, and yeah, was caught instantly.
Okay, interesting. Yeah, this is why we should continue to run meetups and have conferences to spread functional programming.
Mhm.
Yes, let me see. No more questions in the chat. Again, thank you very much, Dieter.
You're welcome.